Hello children, welcome everybody to channel Sube. Today I am going to discuss question number 41 of MCQ part of 2019 Physics new syllabus. A whistling firecracker having a constant whistling frequency is fired vertically upward. It travels initially with an acceleration, then with a deceleration, and finally blasts before coming to the rest. An observer at ground directly below the firecracker listens to the whistling sound of the firecracker. Consider the following statements regarding the frequency of the sound heard by the observer. Statement A: during the acceleration it is higher than the whistling frequency and is decreasing with time. Statement B: during the deceleration it is lower than the whistling frequency and is increasing with time. Statement C: just before the blast it becomes equal to the whistling frequency. Which of the above statements is or are correct? Only A, only B, only C, only A and B, only B and C. So children, you know these types of questions we have to solve by using Doppler equation or Doppler principle. So Doppler principle, we call it Doppler effect. There are various ways it can be expressed. So one way is the Doppler effect is an alteration in the observed frequency of a sound due to motion of either the source or the observer. Then another way to say Doppler effect can be described as the effect produced by a moving source of waves in which there is an apparent upward shift, that is wrong, it may be upward or downward, because here they have not said increased or decreased frequency for observers, so there are some mistakes. This I took from internet because for convenience, otherwise I have to type all these things. Apparent change in frequency of a wave in relation to an observer moving relative words is there to the wave source. Apparent, here also the word apparent is here. Definition: Doppler effect refers to the change. Sometimes we say change, sometimes we can say alteration. Both words are similar in wave frequency during the relative motion between a wave source and the observer. This one is most familiar for the definition we use in advanced level classes. Doppler effect refers to the change in wave frequency. Change means it might increase or decrease according to the direction this observer or the source moves. Frequency during the relative motion between a wave source and its observer. So that means children, so here we can use this diagram to explain it. Imagine that there is an observer at rest. He is not moving, he is at rest, stationary. Then this one is an ambulance having a speaker to make a frequency, the sound. You know, ambulance are like that. So this one is a normal ambulance. So the ambulance also is stationary, at rest. Source and observer both are at rest. Then the ambulance, the speaker sounds, then the sound waves propagate to this way and this way and this way and this way along all the directions. The wave fronts, we call these wave fronts propagate. So you can see at this side and at this side the displacement of these wave fronts are similar. This one and this one, these two lines, this one and this one, all similar. This separation, this distance is referred to lambda, wavelength. So that is the wavelength. So here and here the wavelengths are equal, symmetrical. These rings, wavefronts are symmetrical. So that is what happens when observer and source both are stationary. So now we know this observer is at rest, this source is at rest. So we know these lambda everywhere, lambda values are equal. So according to V equals F lambda, then we can find F equals V divided by lambda. So substituting these values V and lambda, we get a certain frequency. So that frequency is the real frequency of this source, real frequency. We say real frequency, real. So in this question they say whistling frequency to that real frequency. Whistling frequency is the word that they have used. Sometimes we say real frequency, that is because that is the real value of the frequency when both are at rest. So here now having a real frequency to this ambulance, F real, having a real frequency to this ambulance, the ambulance is moving towards the observer. You can see observer is stationary, observer is at rest, but the ambulance is moving towards the observer. So what is the change that we can see in these wavefronts? Wavefronts are packed here, they are very close to each other. Therefore I said that these distances are, these small distances are lambda wavelength. So what has happened to the wavelength at this side? Wavelength has decreased. What has happened to the wavelength at this back of the vehicle? They have increased. So lambda increased here, lambda is been increased here, so lambda is been decreased here. So according to E equals F lambda, then what happens to F? Since V constant because the atmosphere doesn't change, so constant, so therefore V constant, then what happens? Lambda decreases at this side, then F increases. Therefore to keep this, maintain the V value constant. So you can understand that. So now we can therefore write the frequency this observer here, that is we called apparent frequency. Apparent in this definitions you saw apparent frequency, relative. Here apparent frequency, apparent means the frequency that is heard by the observer. So that apparent frequency, that is a single word, we don't have to use all that sentence. So it is called apparent frequency. So apparent frequency increases when the source moves towards the observer. And then, so you have to keep in your mind, you may know that, but if you have forgotten, I remind you. So here what they show in this diagram, the observer is at rest, stationary, not moving. So this vehicle, this ambulance is moving away from the observer. So what happens? Front of the ambulance, the wavefronts are packed very closer to each other. So that means lambda decreased. Lambda has been decreased. So here they are separated more than earlier. So lambda has been increased here. Then the wave, this one here is this one. So lambda increase, therefore frequency decreases. When lambda increases, to maintain the velocity value constant, what happens? Frequency, the lambda increases, frequency decreases. So the apparent frequency in an instant like this, when the sound source moves away from the observer, what happens? The apparent frequency, that means the frequency heard by this observer is this one increase or decrease, frequency decrease. So when the source moving away, when the source sound source move away, frequency decreases. So that you have to keep in your mind clearly. So now let's come to our question. I use the whistling frequency sound of the cracker heard by the observer. I say that is apparent frequency. So I use the word real frequency for this word whistling frequency. So otherwise I can use both for your convenience. So let us draw a small diagram to show illustrate the store in the question. So this one is the observer. So imagine that the whistling firecracker is moving like this upwards, say from here. So the total length, total distance, so it moves upward some height to up to some height, and what happens before come to the acceleration, then with the deceleration, and finally blasts before coming to the rest. Before coming to the rest, what happens? It blasts like this before come to the rest. Come to the rest means come to the velocity change. Before velocity goes to 0, so before velocity approach 0, so that means before. Here say assume the velocity is 0 here. So before it come to the value 0, what happens? Not here then, earlier that thing blasts. So say here it blasts before come to rest, before come to rest here, blast before come to rest. So that means at this point there is a velocity say 2 meter per second. Let us take a value, then it is easier for you to understand. Before come to rest means before the velocity become 0, approach 0, before approach 0, then what happens? It blasts. So at the moment when it blasts, the velocity may be therefore something like this. So then this part we have to divide into two. First part is the accelerating part, The second part is what? Deceleration part. That means minus a deceleration part according to the question. So let us now refer to these statements. During the acceleration, that means this part, during the acceleration it is higher than, what is it is? This one, apparent frequency, regarding the frequency of the sound heard by the observer. That is what they mean, it is here. So the apparent frequency, the frequency that is heard by the observer is higher. So they say the apparent frequency is higher than the real frequency. Apparent frequency is higher than real frequency. So we know when the source is moving away in this diagram, what happens? Frequency must decrease. So the same thing here, the source is moving away from the observer, then frequency must be decreased. But here what has happened? They say increase. So that is wrong. Therefore the frequency, the apparent frequency, that is the frequency heard by this observer, must be lower than the real frequency. Here it must decrease because moving away. So this firecracker also moving away. So therefore apparent frequency, the frequency heard by the observer, must be smaller than the real frequency. But they say what? Whistling frequency and the whistling frequency and is decreasing, not that one, let us discuss that part later. The beginning, it is higher. The apparent frequency is higher, they say, higher. So that is wrong. Therefore, we can say this one is wrong totally. We don't have to check this one, increasing or decreasing, never mind, because this part is wrong at the first try. So therefore totally it is wrong. Then let us go to this statement B. During the deceleration, it is lower than the whistling frequency. That is correct. Lower part is correct because we discussed it like this. During the deceleration also we discussed only about this in this acceleration part. So what is happening in this deceleration part? We don't have to consider, we don't have to think about either it is accelerating or decelerating, it doesn't matter. Only the velocity is the important thing. Here the velocity v, here v, in the equation also v is there. If you refer to the equation, I don't go to the equation because it will be complicated then. So I discuss only the theory. In this part also, what should happen, because this one is moving away, still away in this deceleration part also. Therefore, apparent frequency must be smaller than the real frequency even in this part. In both the parts, that is correct. So but here they say during the deceleration it is lower, so that is correct. It is means this apparent frequency, the frequency heard by the observer, it is lower. So that word is correct. Therefore I mark it is correct than the whistling frequency, and it is increasing. So let us discuss this one later. We don't touch this one now. Keep it away. Keep it aside. Then we don't mark correct or wrong to this one. Later discuss that. Just before the blast. Before the blast means here, having some velocity, because the blast is here. Blast is here. Before the blast means somewhere here. Just before the blast, it becomes equal to the whistling frequency. Frequencies are equal only when these are at rest, both are rest. So the source must be at rest, having a velocity, that means 0. Velocity must be 0. So then only frequencies are equal. This real frequency equal to the frequency apparent, observed frequency. Both are equal, only this condition is fulfilled, that means the velocity 0. So here just before the blast the velocity is not 0, it has a value, then it must be lower. This condition is fulfilled. Then since velocity is since there is a velocity, still it is going away. That means if there is a velocity, still it is going away, because the velocity approach 0 after this blast. It would have approached to 0, but in real time we can't see that, because before that it blasts. So now that condition must be fulfilled. So just before the blast it becomes equal to the whistling frequency. So that is wrong, therefore, because since there is a velocity, it is not at rest. It is not at rest. Then this is the condition. Apparent frequency is smaller than real frequency. So this one is wrong, therefore. Then these both are wrong. A and C are wrong. So we have to again go to the B statement. So we have to check this one. Suppose after checking we can decide that this one is correct, then the answer is only B. Suppose after checking this increasing story is wrong, it is actually decreasing, so we have to mark it is wrong. Then totally this one is wrong, then all are wrong. Then then all are wrong. But there's no such an answer. A and B and C are wrong. There's no such an answer. Therefore, this one is the correct one. We don't have to check this one. Therefore, it is enough. We have discussed that this one. So therefore, since there's no A, B and C all are wrong, there's no such an answer. Therefore, we can choose this one is the correct one. Second one is the answer. So children, I think you can understand. If you are happy, please subscribe my channel, and thank you very much for watching my videos. Do it again and again. So I gave you this, I discussed these Doppler effect definitions, and these diagrams also I used. You can see I tried to make you understand. So you must be happy. So see you tomorrow. Goodbye.